Well, hello and welcome to 8th grade science online. I'm Mr. Dick, and normally I'm teaching the Silver 8 team at Anthony, but it's a pleasure and an honor to be able to teach the rest of the Manhattan 8th graders. So I'll say hi to the Purple 8 from Anthony and the Green and Silver 8 teams from Eisenhower. Hopefully you can learn a few things from us here, not just how not to do a YouTube video, but maybe a few things about science if we get lucky here. So this is the first video in a couple that I'm going to be doing for my little unit this week, and it's designed to supplement the notes that you have. So I have here a copy of the PDF that's also on Canvas there, and you can look at this online, but it would be best if you were to print this up, have this in front of you while we're talking here, and you can add some things to it, highlight it, keep it for the whole week. You're going to use it to answer worksheet questions, to explain things about activities and YouTube videos, and then at the end you'll be answering your assessment questions with the information from this. So if you're going to go back in a week or so and look at this and it's just a bunch of words that you haven't really focused on much, you may not have the understanding that we want at the end there. So anyway, we're not going to talk about Mr. Newton yet. Actually, this is sort of an introductory quick lesson here, kind of the prequel, if you will, because there's a couple of concepts that we have to get down in our heads correctly, or it's just we're not going to have some good understanding. We're actually going to make some mistakes as we try to understand what Newton said. So let's just go ahead and get started on that, because the two words that we're going to talk about, boom, are right here behind me on the board. They're also right there in your notes. Velocity and acceleration. So I don't know what you're thinking. You're thinking, hey, those are common words. We use them all the time. I know. I don't know why I have to listen to this guy here tell us what velocity and acceleration is. But as often is the case in science, words have a little more, maybe a different meaning, a little more specific in details than what we're normally used to in our normal conversations. So my kids are used to me saying this, so I'll introduce to the rest of you. A lot of answers I get from my students, I'll reply with the idea that, hey, you're not wrong. You're just not right enough, okay? So let's see how good you are. Let's see if you can be right enough if I were to ask you, hey, so tell me what velocity is. Da-da-da-da. Yeah, exactly. Velocity is, hey, how fast am I going, all right? That's pretty much it, right? What is my speed? And you are not wrong. Way to go. But guess what? You're just not right enough, because in the world of science, velocity also includes this thing right here, direction. It tells you which way you're going, and that, it turns out, in the world of motion is a really big thing, right? As you might guess, all right? It's not just how fast, but if you're not going in the right direction, some bad things are going to happen here. So, all right? So, hey, velocity and direction, don't forget those. If you're thinking anything that has to do with velocity, don't forget the direction part there. I like to explain velocity with this idea. It describes the motion, and it does it right now. I think your notes say at any given instant. So, boom, what am I doing right now? Now what I'm doing right now. What am I doing right now? All right, so what was I doing at any given instant? That is my velocity. How fast am I going? And don't forget, which direction am I going? All right, so there you go. If you include both of those, you actually are right enough. So congratulations. Let's talk about acceleration. I'm going to stand in front of my acceleration words here. Don't look at your notes either. Let's see if you can be right enough with what acceleration is. 1, 2, 3. What's acceleration? Yep, you're exactly right. It is going faster, okay? But are you right enough? What else could acceleration be anything else? Would you be surprised today to learn that there are 3 ways to accelerate? Well, let me get out of the way and let me tell you this. So we're going to come back to this idea that acceleration is when you change your motion. And if you think about that, my goodness, I mean, that's, if you just look at yourself and think of yourself as just one object, not arms and legs moving all over the place, but I'm just one object, how often a day do I change my motion? I mean, it's thousands of times easily. An automobile just driving across town is going to change its motion almost constantly to the point, all right? There are a few things in the universe whose motion doesn't change, very often, but those are kind of rare, so we're very interested when we talk about Newton's laws about, hey, how can I make something change? What's going to happen if I do this? How is it going to change? I like to be able to know that ahead of time. So acceleration is a change in motion, but wait a minute, what's motion? Motion is velocity. So you could also say acceleration is a change in velocity. But wait a minute, what's velocity? Velocity is speed and what? Direction, you got it. So here we go, let's check this out. Not only can you speed up, that's great, we would call that positive velocity. Slowing down counts as acceleration. Normally you would say negative acceleration, you might even use the word deceleration. All right, so that's okay. And then here's the third way, kind of the surprise one. Don't forget about this because it really turns out to be important. You can just change your direction and you are accelerating. You don't have to speed up or slow down. You can be in your car, driving down the road, 30 miles an hour, speed limit, right? And you start to turn left, and guess what? You're accelerating, and you keep turning left, and you're still accelerating, and you just keep turning left, and you're accelerating, right? And then you stop turning and you go straight again. Now you're not accelerating anymore because you're not changing your speed or your direction, all right? So there we go. So let's quickly review here before we go any farther. How to be right enough with velocity? Speed, did you get that one? Who got the second one? You got direction? Boom. And velocity is describing what's happening like right now, okay? So what happens when velocity or motion changes? We call that acceleration, and there are how many ways to accelerate? Really? 3? Speed up, slow down, turn a corner. There you go. What do you think? If you've got these ideas in your head really strong, then how we're going to describe what Newton is trying to teach you is going to make a lot more sense, and you're going to be able to fully grasp it and not make some incorrect ideas that a lot of people do that we're going to try to avoid here. So, hey, we're almost done. There is one thing that we're leaving out here, and it's killing me, so I'm going to go ahead and just mention it. It's hard to talk about science without talking about measuring things and without doing a little bit of math, at least. Come on. All right? So, obviously, if you think about velocity, you're going to be measuring how far am I going and how much time does it take. I'm going to measure distance and time. All you got to do is divide those two, and voila, you get units like miles per hour, meters per second, etc., and so forth. And then if you take those units and divide it by seconds again, how much time did it take to change my speed? You're going to get some acceleration units there. So there's quite a few math problems we normally do in this unit, and obviously we're leaving them out because of our circumstances here. So I will offer the Math Anyone suggestion. If you email me, I will send you back a worksheet that has a few math problems that we normally did and some equations, and you can work through that, and you can try a couple different things if you'd like. I know that sounds crazy, but it's just killing me not to throw any math in here, so there, I did it. So anyway, I think we're wrapped up here. So I'll say good job, and next time you see me, we're going to be talking about Newton and his laws.